Spring's reawakening signals a new beginning, a transformation of seasons, and a reminder of nature's adaptability and endurance. Once again, the warming earth begins to flower, and the life-sustaining ritual of pollination begins. Without this process, the number and variety of food sources available to man would be drastically reduced. An unmistakable element of spring's arrival is the sound of honeybees, once again foraging flowering plants and blossoms. Deep within the hive, as many as 50,000 bees go about their designated tasks. The colony consists of infertile females called workers. The queen, which is much larger and the only fertile female, is the focal point of each colony. A complex egg-laying machine, she will only leave the hive once to mate with one fertile male, the drone. Drones have a short lifespan, and in that time, it is his one and only duty to mate with a queen. Noticeably larger than a worker, the drone meanders about the colony begging for food, as they are unable to forage for themselves. Toward the end of the season, the drones are starved and forced to leave the hive by the workers. Honeybees collect pollen by using their mandibles to bite and scrape the anthers of the flower. The pollen gathered by the mouthparts is moistened with nectar and is then transferred to the pollen baskets in the hind legs. A bee returns to the hive with a load of pollen and waits for an opportunity to enter. Inside the hive, she will store the multicolored pollen in the cells immediately surrounding the brood. In this location, it is near at hand to be fed to developing larvae, and will also be eaten by newly emerged adult bees. The feather-like structure of the hair on the bee's leg enables them to better retain the pollen for the flight back to the hive. This magnification shows a ball of pollen packed into the fine hairs of a bee's hind leg. Some scientists believe that only man has a form of communication more complicated and superior to that of the honeybee. The language of the honeybee is constructed around intricate and complex dances. A forager returns with its pollen baskets full and begins a series of dances that indicate to the rest of the colony the location of a food source. The round dance is a running motion in figure-8 patterns. The bee stops momentarily for an interested spectator to sample the pollen. This round dance, along with the tasting, is evidence of a food source near the hive. As the bee continues, a tail-wagging dance develops. This dance, along with the round dance, indicates the distance to the food source. After a few moments of continuous activity, the bee will stop and straddle a cell and deposit the load of pollen. A house bee will then pack the pollen into the cell, and other bees that learn the dance will leave the hive to retrieve more pollen and nectar. At the entrance of the hive, the bee's fanning produces an air current that runs throughout the hive, cooling it on warm days. A fanning bee places itself between the combs or directly over the brood to control the temperature. It is this temperature and humidity control that contributes to a strong, healthy brood and a large store of honey. The very existence of the hive revolves around the queen. The major difference between the queen and the workers, which are also female, is that the queen's reproductive organs are fully developed, unlike the organs of her sisters, which are only partially developed and do not allow them to lay eggs. The queen's attendants feed her as she continues her endless task of laying eggs. A familiar sight in the early spring is a swarm of bees hanging from a tree limb. Within this mass of bees is the queen, who has left the hive, taking several thousand bees with her. When the hive becomes overpopulated or a new queen has hatched, this swarming will occur. To demonstrate how a swarm of bees will leave an established hive, the queen is captured. And placed in a small queen cage, which is secured to a tree limb at the original site of the hive. The hive box and comb is then moved away. The bees in the hive are shaken off the frames. Amazingly, the bees know their own queen and will return to her and not to the hive box. Although this phenomenon takes about 30 minutes, our time-lapse camera has compressed it into 20 seconds. The result is a swarm of bees demonstrating incredible loyalty to their queen. Inside the queen's reproductive organs are the developing eggs. During the height of the honey-producing season, a strong queen will lay up to 3,000 eggs each day, placing them gently at the bottom of the cells. These eggs will be fed with bee milk, a white, milky substance the nurse bees develop after eating pollen and nectar. At 8 to 9 days, the cells are capped and the pupae stage begins. A cutaway section of capped cells reveal pupae with developing eyes, about 15 days progress. An almost completely developed bee has begun to move within the cell. One task remains before the new bee can join the colony. It must chew away the capping on the cell to release itself. Just 21 days after the egg has been laid, a fully grown adult emerges. Her first stop is honey, where she will eat to build her strength. In a few hours, this young worker bee will begin her duties as a house bee. Her 30 to 40 day lifespan will demand some 10 different jobs within the colony. Perhaps the best known part of the bee's anatomy is the sting. Should a bee become intimidated, it will sting to protect the colony. A bee is placed on the arm and antagonized until it stings. The barbs in the sting become hooked into the skin. The bee turns and pulls, eventually tearing the sting from its body. The muscles of the sting sac continue to throb, injecting the venom into the wound for a few moments. Under magnification, venom is seen dripping from the end of the sting. Bee venom has been used to reduce, and in some cases, it is said to have cured such human diseases as arthritis. In the spring, the activity at the entrance of the hive is evidence of a growing colony of bees. As the numbers in the hive increase during the honey-producing season, a swarm may develop. When this occurs, the queen leaves with approximately half of the worker bees to establish a new colony. A bee loaded with pollen returns to a swarm, which has established a home between the ceiling and second floor of an apartment building. Inside the ceiling, a thriving hive is discovered. The beekeeper will remove the entire nest to an apiary, where they will continue to build comb and produce honey. If the comb is not removed and the cracks and holes filled, it is likely another bee colony will soon return. Swarms that are looking for a new home are also found in conspicuous places like this tree in the front yard of a home on a busy street. The cluster awaits scout bees that are out searching for a permanent home. Although a frightful sight, bees are actually quite docile when swarming. A knowledgeable beekeeper will have no trouble capturing them. When he locates the queen, usually at the top of the cluster, he shakes the branch over the hive. Most of the bees, including the queen, fall into the box. With a little brushing and smoke, the remaining bees walk into the hive box. The captured swarm will be transported by the beekeeper to join other hives that will produce hundreds of gallons of honey. The honeybee's relationship to man extends back beyond recorded history. Written records reveal that migratory beekeeping up and down the Nile River in ancient Egypt was a common practice. Aristotle studied honeybees and wrote extensively about them. The Roman poet Virgil was also a beekeeper. Paleolithic paintings in Spain represent men taking honeycomb from a swarm of bees. The date of the painting is thought to be 15,000 BC. Beekeeping is for those who love nature in its purest form. The beekeeper has the opportunity to see in his craft the colorful and intricately complex patterns that are products of eons of trial and error. He is in many ways simply a caretaker, providing for a part of nature that in turn helps sustain his own species. To establish a new hive or strengthen an old hive, many beekeepers purchase package bees. About 3,000 workers, a few drones, and one queen who has been artificially inseminated. The bees are transported through the mail in a screened package with a can of sugar water to feed them. The queen is in a much smaller cage inside the package of bees. The smaller queen cage is removed, and a cork is taken out of one end, revealing a piece of candy, which will be eaten by the worker bees to release the queen and introduce her gradually to her new home. In this way, the bees will work as a single unit and begin working for the queen.
So we place the queen cage in the center of the hive between frames. This way when the queen is released, she'll be able to start work immediately. Now I'll get the other bees that are in the traveling cage. We'll introduce them into the hive. Pour them right over the queen cage so that they can. You'll notice that some of the bees have already found the queen cage. I'm going to remove the can of sugar water that's in their food on their trip. Take those bees off. And we're going to pour the bees in the cage directly over the queen cage.
After the packaged bees are released into the hive box, the workers will begin working immediately to release her, while others begin building comb.
Once the bees start cleaning house, they will remove all the dead bees from the hive.
Since the queen has been artificially inseminated, she will start laying eggs as soon as brood comb is ready.
They'll eventually work their way out.
In apiaries with hundreds of hives, each bee knows its own queen.
They're communicating with her, and they're already starting to.
A variety of flowers are quickly located by the honeybees. From these varied blossoms, the foragers transport pollen and nectar back to the hive. Their foraging will take them up to 3 miles away. A bee surveys the building progress. It seems impossible that these tiny creatures will build a thriving community in only a few days. By using their mandibles and wax produced from glands on the underside of their body, the bees form the perfectly shaped hexagonal cells. Five millimeters in diameter and 15 millimeters in depth, the hexagonal design gives the honeycomb unusual strength. A piece of wax comb weighing only 1 1/2 ounces will hold about 4 pounds of honey. When the colony senses that the existing queen is becoming too old or sick, or has died, the workers will construct a queen cell. It is an elongated, peanut-shaped cell, usually occupying the space of about 3 normal cells. A stronger, more potent food called royal jelly is fed to a normal worker larvae. The full-grown queen, using her sharp mandibles, will cut her way out of the cell, emerging to become the new driving force of the hive. If more than one queen continues to exist in the same hive, they will find each other, and to determine which will lead the hive, they will fight to the death. Attendant bees attempt to groom their queen, while the combatants frantically search for one another. One attendant bee chases the opposing queen away and tries to sting her. It will be the stronger and the most resourceful of the two that will win. This is the only time the queen will use her sting. However, death usually results in a strong lock of the mandibles between the thorax and abdomen, which will dismember the loser. The eerie cry of the battle is a reminder of how serious the struggle for survival and control in nature can be. After weeks of hot, dry weather, a summer rain shower crosses the fields, cooling the beehives. The bees' adaptability shows they are survivalists in almost any environment. As part of the NASA space program, honeybees were part of an experiment to study how they would adapt to the environment and weightlessness of space.
Okay, start into this thing. What we have here is a shuttle student involvement program experiment. It's a little enclosure module here with 3,300 Italian honeybees in it. It was launched when the bees were approximately 12 days old. They stuck all 3,300 of these bees in here. The enclosure module has a little compartment down here that they fit in, and then they go into through a little door right into this part, and into 3 little sections with screens on it that they could possibly build their honeycomb. Up in this end is a feeder, and the feeder feeds them with an agar solution with some sort of a jelly on it. It's a Chinese jelly. The bees, when we first launched, looked like they were in great shape, and most of them were down in this area. They slowly moved their way up into the area where the food was, and they've really been going to town. Right now, they've got a great big old honeycomb. We'll show you a little closer here in a second. That's going right in here, and it goes almost all the way down into this area here.
Okay, another thing we've noticed is 2 little thermometers in this cage, and when the bees are feeding the honey, they can measure the temperature. And when the bees are feeding the honey, they can measure the temperature of the honey. And The ambient temperature on this side where there aren't very many bees is about 80 degrees, and up where the hive is, they built their hive right on the other thermometer, or their comb, and they keep it about 90 degrees up there. On this side of the little module is a hole, and the bees have sent up a whole sequence of workers that are all just clinging to the top of the plexiglass there and fanning their wings, and they're fanning the air in here up past the comb and then back down again. And they keep pretty much bunched up together except for the little path where they're keeping an airflow. Down in this region by the food, there's a chain of bees about 2 inches thick. It's just like a rope that goes from way over here all the way back over to the hive.
The honey produced by the bees throughout the season will be the primary food source for the entire hive. With good management, a strong colony will produce excesses of honey that can be harvested by the beekeeper. In the late summer, the honey harvest begins. This beekeeping family comes to inspect some of their hives and to remove part of the honey produced. They will leave enough honey on each hive to feed the bees through winter. A smoker is used to push the bees down into the hive. Then, a felt board coated with almond extract is placed on top of the hive. The strong odor will drive the bees out of the hive long enough for the beekeepers to do their work. These supers, the small boxes above the brood chamber, contain the frames of honey. Fully ripened honey is known by the thin, pure white wax capping all the cells. Working quickly and efficiently, the beekeepers will examine over 100 hives on this day. Empty frames and supers are replaced as rapidly as possible to allow the bees to return to the hives and resume their normal activity. On an August afternoon, the work is hot, but the heavy supers mean that the season's labors will be rewarded. Later in the day, the supers filled with honey are taken to the honey house, where the honey will be extracted from the frames. Each super should yield about 30 pounds of honey, and a properly managed hive should produce 100 to 150 pounds in total. A decapping machine automatically cuts the cappings off the honeycomb. As the cappings are removed, the entire building is filled with the sweet fragrance of fresh honey. The frames are placed in an extractor, which will remove the honey by centrifugal force. The only other processing is the straining of leftover pieces of comb wax. The product, pure honey. The season has been a success. The honey harvest has been good. In all of nature's labyrinth of variety and species, none has maintained its ancient social structure while becoming so essential to the survival of man as the honeybee. To kill our pollinators reduces another element in the ecological system. Man is to some degree nature's caretaker, and we must preserve those things that guarantee our existence.